For this video, we're going to discuss a little bit more about synthetic division. So here we have our quadratic trinomial, and you notice there's no degrees missing. And we're going to divide it by this binomial. But when we use synthetic division, our leading coefficient here has to be a 1. So the way we can fix that is to take the 2x minus 3 and factor a 2 out, which leaves us with an x minus, and then 3 over 2 is going to leave us with 3 over 2. So during our synthetic division, we're going to use the opposite of negative 3 halves during division. Now I factored a 2 out of this one, which means I have to factor a 2 out of everything up here as well. So when I factor a 2 out of that, I'll end up with a 2 for the x squared, a negative 1 for the x, and a positive 3 for the 6. So I can go ahead and start doing my synthetic division. So I'll have negative 3 over 2. That's what I'm sorry, positive 3 over 2. It's opposite. That's what I'm going to divide with. And I'm going to use the factors, or the coefficients of 2, negative 1, and 3 instead of 4, 2, and 6. Now one thing I want to remember at the end is if we happen to have a remainder, we have to multiply back through by 2. So let's bring the 2 over, the negative 1, and the 3. So this is a degree of 2, degree of 1, degree of 0. We're going to bring down our 2 first. And then 3 halves times 2 leaves us with a 3. And negative 1 plus 3 is 2. And then 3 halves times 2 will give us a 3. And 3 plus 3 gives us a 6. And since we went from a degree of 2, 1, 0, this is going to be a first degree, 0 degree, and this right here ends up being the remainder. So we're going to take our 2, bring it down, and we had an x squared divided by x to the first, and that leaves us with an x to the first, so 2x, and then my constant term would be a 2, 2x plus 2. Now remember my remainder, I can't just take the remainder and put it over the original problem of 2x minus 3 because I factored a 2 out of that. So that remainder would normally be over this number. But I still have to use 2x minus 3, so the way we fix that is to take our remainder and times it back by 2, and that will give us a 12. So now we're going to use 12 over 2x minus 3. One of the most common mistakes is to forget to take this 6 and multiply it by whatever you factored out of the original problem over here, which is 2. So this right here ends up being our final quotient. The next problem down, you'll see here we have a 4 degree, then it goes to a 2 degree, so we're skipping over a 3rd degree. When dividing, we can never skip over any degrees, so we're going to have to insert into there a 0p to the 3rd. So I will use a 0 here. Again, I still have a leading coefficient that is not a 1, so I'm going to refactor that as 2p minus 3 over 2. So I'm going to use the opposite of minus p here, or minus 3 over 2. So the opposite of that is positive 3 over 2. But I also have to factor 2 out of each of these. 4 divided by 2 is going to give me 2. That's what I'm using, 2. I have a 0p, so 0 divided by 2 is just 0. So this is my 4th degree, this is my 3rd degree. I also need a 2, 1, and a 0 degree. Now my 2nd degree term is the negative 17, but instead of dividing it by 2, I'm just going to leave it as negative 17 over 2. And my 1st degree term, which is this one right here, gives me a 14 over 2, which is 7. And my 0 degree, which is my constant term, negative 3, I'm going to just leave that as negative 3 over 2. So these are the numbers I'm going to use when I divide. I'm going to bring my first number down, which is a 2. And I'm going to start multiplying. So 3 halves times 2, 6 over 2, and 6 over 2 is 3. I could just call that 3. 0 plus 3 is 3. Now multiply again. So 3 over 2 times 3 is going to give me 9 over 2. And negative 17 plus the 9 here is going to give me a negative 8 It's going to give me negative 8 over 2, which is really negative 4, so I'm going to write it as negative 4. And now 3 halves times negative 4, that's going to give me negative 12 over 2, which is negative 6. Add these up, and I get a positive 1. And then 3 halves times 1 is 3 over 2, and these two, this is where our remainder, if we have one, would be located. This is going to end up canceling out, leaving us a remainder of 0. So these become my new coefficients, and that should be my constant value. Now, to tell which one we start off with, we go back to the original problem, which has a p to the 4th, and the first thing we're going to do is divide it by a p to the 1st, and that leaves us with a p to the 3rd. So this first one right here is rewritten as 2p to the 3rd. Then I just decrease my degree as I go, so I have a plus 3p to the 2nd minus 4p to the 1st plus 1. Now, since I didn't have a remainder here, I did not have to go back and multiply by 2 the way that I did up here. So you got to be careful of that.